Hi everyone, welcome back to another video. Today I'm going to show you how to control the temperature and humidity with an AC fan. This is building off of my previous video, which I discussed how to control an AC fan using an Arduino Nano. This code is going to be using a display to set the fan speeds and temperature and humidity targets and a few other settings. So if you haven't watched my previous video, which describes how to control an AC fan, I suggest you watch that first, because I'm going to build off the knowledge I discussed in that. With that said, I'm going to be using an ESP32 for this sketch, because the fan code, the fan speed control code is going to be running on core 1, and all the other tasks, that being the display, the touch events, the reading of sensors, and working out the correct fan speeds from the temperature and humidity compared to the user set points. I'll explain that a bit more in a second, but as I said, based off of my previous video, I discussed that the fan code, the code that does the AC trimming, or should I say the trimming of the AC sine wave, that must run very, very fast. When I say fast, I mean in the microseconds, preferably less than 10 microseconds. Again, that is discussed in my previous video. So that is why I'm going to be using an ESP32, because it allows us to integrate the code to run the fan on one core and our graphics display and sensor reading on the second core. Otherwise, you'd be using a Nano connected to another Arduino, be that another Nano or a Mega or whatever, via I2C, which obviously then requires 2 MCUs and some wiring, extra complexities. So I thought it would be easier to put it all on one chip. Here we can see the code, so there's no point googling that library because I made my own graphics library. If you haven't seen some of my other videos, I've made some like Mario games and other such things. So I made my own library for the ST7735 for an ESP32, which uses a display buffer and it runs at over 30 FPS. So if you want to use this code, you could either use another library or you can use my supplied library. It is stable, but it doesn't have loads of functions, should I say. It has all the core ones, but I'm drifting off the point here. Anyway, so this is the code that's going to be running on the ESP32. And as I said, this is going to control the 2 AC fans, and it's going to control a TFT display, 5 buttons, an air heater. We have a speaker that could either be an actual speaker or I think it's a passive buzzer, is it? Yes, that's the one that has to be externally driven. And of course we have our DHT32. This is just some calculations to, or should I say, some pre-calculations to work out the registry value for the fan 1 and fan 2 pin, so I don't have to do it in my, what effectively is my interrupt event. I'll explain that a bit more in a minute. Here we've got something to keep track of how long the user's been away, so effectively the last time they pressed a key. I have a lock for the EEPROM. I use this to know if the device hasn't been set for the first time or if they've reset the settings. If this key doesn't match the first block in the EEPROM, it would save all the values, therefore automatically populating EEPROM. I've got a variable again for if the display is off. It automatically saves the values once it goes back to the home page, which happens automatically after the AFK time or if the user returns after adjusting some values. Therefore, we don't kill the EEPROM. Not that this ESP has an EEPROM. I believe it actually writes it to the flash. AFK time, same stuff. Default relay state. Some relays are high or low by default, so set that to whatever state your relay works to be turned off. No, turn on, sorry, turn on. I should change that to be a bit more descriptive. This is just some stuff for the speaker, user fan speeds, some stuff to keep track of the menu. The home page has a slider. We have 7 max pages, and then of those pages, they have sub-pages of a varying amount, as you can see. I'll explain this more in a minute. Really, this tutorial is more about controlling fans, but I'll just go over the initial variables. Something to know if the users lock the page in place. This is for the slider to automatically go to the next position. And then we have some max-min histories that we keep track of. And then these are the user variables. I use namespaces just so I can know what value I'm referring to, if it's a user variable or a sensor variable or a fan variable or a device. I would have put system in there, but that namespace is already reserved. Not by me, by some other code, some core library. What we got here. So yes, this is a new feature I added over the week. So this is effectively the speed at which your fan will no longer turn. So the stalling speed. Because some big fans would generally just not run with a very heavily trimmed sine wave. So therefore you set the default, you set the stall speed, and then it maps the remaining timing left after that to 100 values. So you still get 100 fan speeds, but it just maps from the stall speed to 100%. So that's good. That means we get ultimate control over our fan speed. Something to disable buzzer, background color. I don't need to describe all of these. Timeout time in minutes. Target min and max temperature. This is the user set points. And I also have a Fahrenheit one, so they're completely separate, so you don't have to do any calculations, and then it's always slightly off when it goes backwards and forwards because you're using floating points and stuff. So it's actually more effective to have separate values for Fahrenheit and Celsius. That may seem convoluted, but I assure you it's the more professional way to do things. Obviously humidity doesn't have a different value, so that's just one humidity max min, target minimum max fan speeds. We can disable either of the fans if we want. We can set the fans to fixed speeds if we want, so that they just remain at the speed that you set. You can choose to control temperature and humidity, or one or the other. And if you want your temperature in Fahrenheit. Obviously we've got our sensor values. As I said, we've got one of each for the temperature and just one for humidity. And then this is exactly the same as my previous video. This is just our variables that we required to trim the sine wave. So this is by default it's set to 50 Hz, half sine wave interval. 0 cross, read 0 cross is true. Now you're going to look at this code and I'm going to have to explain it a bit because you're going to wonder why I'm not using an interrupt. I'll get to that soon. I was, but I'm not anymore. Fan 1 timing, fan 2 time default is at 0, so the fans will start turned off. But then that is adjusted when it reads the user fan speeds. Fan 1 cut off and fan 2 cut off. We don't want to trim the sine wave yet, and their timings, their previous timings. And then just some stuff for library instances, task handlers, because we're using 2 cores. I've set task 2, which is my high priority task. I've loaded it into the RAM, so it's supposedly faster. It's not, but I put it there anyway. It's meant to be faster. I'm not using a mutex at the moment, but that was just to lock some variables, but I don't need that at the moment. So we can kind of ignore that. And then disable some pin modes. That's for that's actually for creating tones. I don't think I need to know this. Yep, so here we allocate some EEPROM from the flash. We try and allocate 64 bytes. I think it has to be to the power of 8, otherwise it will always fail. And if we can allocate it, looks as though not. If we can, then we can load the EEPROM. Then we'll set the fan speeds from whatever they were prior. What's quite important is I'm giving tasks to the highest priority possible. higher than all the other system tasks. It's a bit of a dark art trying to get an ESP to loop really quickly without crashing, and I'll discuss that too. Obviously I've overcome it. I don't know if I need to discuss all this button kind of stuff. Oh, that was my doggy's dinner ready. So what we've got here, oh he's coming down. So we have 5 buttons in this code. The left and right buttons are to set any of the values, so by that I mean user variables. And the up and down buttons are purely just to go through pages. And then the center button is to lock a page in place or to select a value in the menu. And then we have something to keep track of if no other button is pressed, because it's all else if else if. If no button is pressed, then we'll start incrementing the AFK time once every minute. And you do need to remember to reset that if a user presses a button, as well as the AFK time. Otherwise, if you didn't reset the meals and you only reset the AFK time, then you'd get it increment, because that could be just about to roll over. What else we got? So yeah, setting page values. As I said, don't really need to go over this. Home page doesn't have anything but a slider, so you can press left and right to go through the slider positions. Temperature page, we can adjust either the Fahrenheit or the Celsius value, as I said, depending on what mode they have it in. And as I said, we then tell it that we want to save the values if they've pressed one of the buttons and it's in this state, because therefore it's definitely adjusted one of these values. Same to be said for all the other pages really. I don't think I need to discuss it. This is obviously all my own functions. Same for fan 1. We can either have the fan in a fixed speed. If the fan's in a fixed speed, the max speed will then be set to the min speed, and then they'll both be adjusted at the same time because we're setting a fixed speed. Else, if it's not in a fixed speed mode, then we're just adjusting the minimum temperature here. And we can see that if the fan speed is not 0 and the fan speed is less than target max, then this is basically saying that if we've set it to 0 if the fan was off and they've pressed this button, it will automatically jump up to the minimum speed, because if they turn the fan off, the speed would be 0, and therefore as soon as they go into this page, it would go right back up to the minimum speed at the speed of about 32 FPS, so they wouldn't even see it happen. Same for subpage 1. So this is the maximum speed, that's the minimum speed, because this is subpage 0, and that's subpage 1. Basically exactly the same for fan 2, but it's just fan 2. It's quite literally, I could actually just turn it into a function, but really there's no need to copy it into a function if I'm just doing it twice. History page has no values to adjust. Settings page. Because this works by returning -1 or 1 to adjust the values. Here we got a underscore increment, which is passed to the function, depending if they pressed up or down. We actually have to use a ternary to then convert that to true or false, because -1 and 0 would both be false. Neither is true. So therefore we're saying if it's less than 0, it's false. Otherwise, if it's that, then it's true. So yeah, that's nice and easy. We can adjust, as I said, the fan 1 stall speeds up to 50%, in my opinion, personal opinion. I wouldn't say professional opinion because I'm not a fan expert, but I see no reason why the stall speed of a fan should be any greater than 50%. Surely they're doing something wrong if that's the case. So I've limited the stall speed to 50% of the fan. Here's the adjust value function. Don't need to describe that. EEPROM standard stuff. I won't go over all of that. That would be ridiculous. But that's what I was on about earlier on. If the EEPROM block 0 does not equal the EEPROM key, then we need to populate the EEPROM for the first time, or same if they reset it. Else we can load the settings. Standard stuff. I say standard stuff, it's the same in all my projects. I've done that same kind of code for years and years. Now I've seen no reason to describe the whole menu. I don't know why I've described the other stuff really. But it's just giving you an insight how the code works, I suppose. So slide down the home page, increments every 10 seconds up to the maximum position as it rolls back. Do I discuss this? I really see it being a waste of time. You're all here just to control a fan. But in my previous video, I've told you how to control a fan. I suppose this is more a graphical based fan controller, so I will somewhat skim over this. As I said, there is multiple pages. This is the home slider, so there'll be multiple positions. There's one for the temperature here. Here, as I said, we're either going to be, by default, it'll be set to the Celsius that it'll be displaying. Else, if they're in Fahrenheit, it would display the temperature Fahrenheit in Fahrenheit, which is actually a true reading, not a conversion. Not that a conversion's completely inaccurate, but it's good not to have to do any floating point calculations backwards and forwards between Fahrenheit and Celsius. If they was to keep changing it back and forward, I would expect to see it start rounding the numbers if they're close to 0, which you don't want. Anyway, so yeah, it would change if they're in Fahrenheit. I've written it so that it will center the value, standard kind of stuff. If it's less than 10, put the start X at 35, which is about the correct position on the display to center that value. Else we're going to start knocking it back by, now you're going to probably wonder why it's that, but 100 is only a small amount greater because it will never be 200, so I didn't see it to go that much more. So the numbers aren't completely linear, but nonetheless you can see how it works. Loads of boring stuff there. Is it Fahrenheit or Celsius? Then we've got a humidity page. You'll be able to read this code itself, so I won't need to go over all of it. Yeah, temperature page. So this is actually the menu here. It looks rather odd, but that's how it is. Yeah, I see no reason to go over that. Let's start getting to the good stuff. So here's our task 1 code. So as I said, we've got a task defined to each, or pinned to each core. This is the function to stop the ESP crashing. You have to call this each loop, and it basically tells the watchdog to reset itself. Not the timing of itself, but just reset its protecting mode. So that stops us crashing, and it's completely effective. And that will work for both the cores. Screensaver. I made a funny little screensaver. I got bored. It's really simple code, but it just basically gets the text to bounce around the screen like the old school Windows XP screensaver. Obviously we're going to read our sensors. I had to use a special library, a library purposely made for the ESP to actually get it to read the DHT22 without getting loads of error readings. And trust me, they are weird readings, like 999 humidity value, which is obviously impossible. So, yeah, you had to use a special library there for the DHT. As I said, we're getting independent values, and then we're going to set our max mins. Now, this is the bit that you've all came for, really. It is, in fact, because in my previous video I told you how to control a fan, but you're all here to know how to control a fan with the temperature and humidity being the factor. So, this is going to take some explanation. So, where do I start? I suppose from the top. We have some enums. So, if you want this is a state for each one. So, do we want to go, is the temperature by default? By default, it'll be okay. Adjust temp, adjust hum, they're okay. That means they won't be adjusted either, or they're going to be adjusted down or up. So, nice and human readable. We have our previous mils here, which is going to be used for this. Fan 1, previous speed, and fan 2 PC, obviously going to be 0. Temperature, previous temperature option, and previous hum option equals 4. Now that's annoying, because I can't remember. We're going to have to go over to that in a second. I wonder if I even still use that. We'll see in a second. I don't know why I've said that before. As I said, we're going to do some conversions here. So by default, we'll start with Celsius, and if it's in Fahrenheit, then we use the Fahrenheit set points and sensor reading. as our comparisons for whether they're out of range. And then we're going to be adjusting the fan speed every 2 seconds. Now that's 100 speed possibly. I say possibly, it depends what your minimum fan speed is. So let's say you have it set to 25 and maximum of 100. That's normally what I have it as. That means we've got 75 speeds. But in worst case scenario, your minimum fan speed is 0 because you set the stall speed correctly. And the max speed is 100. That'd be 2 times 100. That's 200 seconds. That's about 3 minutes 20 seconds. So that's how long it would take for the fan to go from its minimum speed to its maximum speed. You don't want it to happen straight away because you want to try and catch the point where the humidity or temperature or both is in range, and then the fan will stay at that given speed. Obviously it would reduce its speed if then the range goes out, or increase its speed depending, but the point is you're going to try and slowly ramp it up so that you get to the point where the fan speed and the temperature correspond. You understand what I'm saying? So with that said, 2-second timer. You could adjust it if you want it longer. Depends how big your environment is, I suppose. I thought that would be too much of a complex thing to put in the menu. I've only got so many chars I can fit in the menu, so it'd be hard to tactically write it as something. What would you say? I can't fit. I would love to call it fan speed increment time, but you can't fit that under display. I can't put it as fan inc time because no one will know what I'm on about. So I was kind of left with a dilemma there, more of a GUI based dilemma, or should I say UX, user experience. Anyway, so let's get past that. If the temperature is less than the min temperature, then obviously we want to adjust the temperature up. If it's less than the maximum temperature, we want to adjust it down. If the humidity is less than... Ints, get out from under there. What is he doing? I think he's literally licking his wang then. If the temperature, if the humidity is less than the target min humidity, adjust ham up. And if the humidity is greater than the max humidity, I want it to go down. What were you doing under the rinse? I'll question you. This is just for debugging, because I want to know what mode it chose. So, literally just printing it out. Complete views. Ah, so that was my previous temp option. That's why I had it for, because it's just for debugging, so I didn't actually set it to something human readable. Basically, I'm putting it out of range because I don't want it to be up, down, or OK, which would be 0, 1, or 2. So I could have actually set it to 3. I was obviously probably a bit tired at the time before it counted it. No, an enum does start from 1. It's 1, 2, 3. Or is it 0, 1, 2? Well, that's probably why I put it for. Safe either way. Either way, print out what option it chose so we get a bit of feedback as we can break down what's going on. Now, as I said, if the fan is in a fixed speed, then we're just going to say straight away, alright, fan 1 speed equals their target minimum speed, because the minimum max speed when on fixed speed will be the same. Else, if they've disabled the fan, as I said, the speed will be set to 0. Same for fan 2 here, quite literally. And then, as I said, we've got an air heater. So, and as I said, we're using a default relay state variable. So basically, not default relay state. So if you had to set to low, that'd be high, and then that'd be low. Basically, that's turning the relay on and off. Now, this is more to the point. If the user wants to control the temperature and not the humidity, we're just controlling the temperature. If they want to adjust the temperature up, nice and simple. If the fan speed is greater than the target minimum speed and they haven't disabled the fan and it's not in fixed speed mode, then we can decrease the fan speed. Same for fan 2. If they want to do the temperature, if the temperature is set to go down, then we also need to increase the fan speed. Therefore, we're going to increase the fan speed. Note the variable that's de-incrementing it by -1, and that's incrementing it by 1. So fan speed's going down, fan speed's going up. Other than that, the functions are exactly the same. Now, other way around. If the user has set it to not control the temperature and only control the humidity, then in that case, same kind of scenario. If they want to adjust it, if it's set to adjust the humidity up from what it's worked up here, if it's set to go up, so we want to get the humidity to go up, we're going to decrease the fan speed because the environment creates quite a lot of humidity. So therefore you're going to start retaining a lot of humidity in the atmosphere. Otherwise, if we want to get the humidity down, we're going to suck loads of air from outside and just literally get it to the point where whatever the humidity outside is going to be the best that we can achieve inside. Obviously, unless you have some kind of dehumidifier running at the same time. But I haven't put that in. I suppose I could put in an extra pin for a dehumidifier, wouldn't be the word. But that's not in at the moment. But you can see what I mean. So that's how we're doing it for those two modes. Now this is where it gets a bit more complex. They've now set it to control temperature and humidity. Well, we've got a dilemma here. You've got your intake fan and your outtake fan. They both have to run linear to each other. Obviously, you probably set the fan to, let's say your intake fan to run a bit slower so you have a negative environment. But nonetheless, they need to still be within range of each other so they're not overworking. So you can't just slow down one fan to try and increase the humidity and speed up the other fan to try and decrease the temperature. That won't work. You have to do one or the other. It's a fine art. So let's discuss that then. So we've got the dilemma that we want to control the temperature and the humidity, but we can, even if we have two fans, they still have to be running linear to each other so that the pressure isn't positive or really negative. Otherwise, we're just going to be either blowing loads of air out or sucking it through all the cracks and stuff. So what do we do? Again, we've got an enum here. So at the moment, so this is in dual mode here. So it's either going to be not set, fan RPM up, or fan RPM down. By default, the fan mode is set to not set. We're going to do some calculations again. We've already got our previous things up here that said what should we be doing. They may both be true. It may be saying adjust temperature up, adjust hum up. It may be saying adjust temperature down and hum up, or vice versa. One could be wanting to go up and the other could be going down, or they could be both down or both up. Worst case scenario, one is up, one is down. What do we do? Well, we're going to have to go on a percent out of range basis, aren't we? So we've got to this point. We've then said if it's wanting to adjust the temperature up, let's work out the temperature out of range compared to the target minimum temperature and the temperature. This has already been converted if they're in Fahrenheit or Celsius just above. That's why it's just saying temperature there, not the enum. So, sorry, not the enum, not the namespaced one. So that would have been sensor temperature otherwise. Temperature C, temperature F. Let's just back that up. Yeah, temperature C, temperature F. So, with that said, I was drifting off there, but if it's adjust temperature up, percent out of range, we're wanting to go up, so therefore, if we're wanting to go up, the temperature must be lower than their minimum temperature set point. So we're going to compare the minimum temperature set point to the temperature and work out how much of a percent it is out of range. Otherwise, if it's down, then we're obviously greater than the max temperature, so we do, again, percent out of range, and we're setting that to the temperature out of range. Same principle for the humidity, minimum and the maximum for either or. Not either or, either. Sorry. Now, once those are set, we can then say, is the temperature out of range greater than the humidity out of range? Temperature having priority because temperature in most growing environments is the most important thing. So, well it is. If the temperature out of range is greater than the humidity out of range, then we're going to just focus on the temperature. If the temperature needs to go up, then obviously the fans need to, oh, did I do that backwards? I have. I only wrote this a few days ago. If we want to adjust the temperature, oh no I did. If adjust temp up, then the fans want to slow down. Sorry, I misinterpreted my own code there, even with the most human readable, most format. Anyway, if we want to adjust the temperature up, then obviously we need to slow the fans down. Else, if we want to adjust the temperature down, then we want to speed the fans up. Simple, simple. Else, if the temperature out of range is not greater than the humidity out of range, then it's possible that the humidity out of range is a given value, i.e. it's greater than 0. So we're not going to do that comparison just to make the code quicker, because we're already going to check if it's set to up or down. Remember, it'd either be up, down, or okay. Going up here, up, down, or previous, okay, where is it set to? But by default up here it's set to okay. And that's not static, so therefore it's reset each time this function's called. So by default it's okay. If it's not set here, then it's still okay. We're going all the way down. Is it set to up or down? In here. If it's up, same kind of principle. We want to adjust the temperature up, humidity up, sorry. Let's slow down the fan. If you want to do it the other way, speed the fan up. Now that we've worked out percent out of range and worked out what the fans want to do, nice and simple for cool here. If the fan mode equals RPM down, then if the fan 1 speed is greater than the minimum speed, reduce the fan speed by 1%. Same for fan 2. And the same principle if the RPM is up. If the fans, so I need to cough there. If the fan is less, the fan speed is less than the maximum speed, increase it by 1%. Same for fan 2. And then reset the previous mils. So that's going to be cooled every 2 seconds till the fan until either the temperature or the humidity says it's okay, or the fan inevitably reaches its minimum or maximum speed. Because obviously in some scenarios you may not ever be able to achieve your temperature set point. Let's say it's 40 Celsius outside in the summer and you've set it to 27 Celsius, 26.5 Celsius, and you don't have any AC. You're never going to probably achieve your temperature, so it's just going to always sit at 100% trying to do the best it can. But that's just the scenario. In some cases, it may be nice and cold outside, so you're going to be sucking in really cold air, and it's probably only going to need to go to 40%, and then it would say that the value is okay, in which case the fan would stay at that speed, and you may find that over time the temperature will then start to become too low, and obviously then it would start to slow the fan speed down. It's always looping, obviously every 2 seconds. And then we get to the point here, so if the fan 1 speed is not equal to the previous speed, that was set to 0, and the fan starts at 0, so therefore if that is 0 and that is 0, there's no need to call this function, or should I say, read this subroutine. But yep, if the fan speed has changed, then we'll print it out just for debugging, and then we're going to start saying if the fan 1 pin is low, digital right fan pin low, because here we're saying, sorry, I missed over the step here. If the fan 1 speed is not equal to the previous speed, if the fan speed is 0, because this could change throughout all of here, because this is the only place it's getting cooled, the user could have done it, it could be, the minimum speed could be 0. If the fan speed equals 0, let's just turn off the AC. By that I mean the fan's completely turned off. Timing set to 0 and finish cutoff false. We don't need to call any functions to start cutting up the sine wave effectively. Else if the fan speed is 100%, then all we need to do is just turn the AC on constantly. Again, we don't need to mess with the AC sine wave. Else if it's not 0 or 100%, therefore it's a speed that requires sine wave trimming. So then we need to work out the timing for the sine wave trim. And as I said, we've got a stall speed here. I've tried to write this function as small as possible. I keep calling it a function. It's a calculation, that is. If the fan 1 timing, we then set that to there, so that's effectively working out the minimum timing for the user stall speed. And then here it's using that to take their value and add the min timing. I could explain this calculation, but I get in weird little states where I manage to write calculations without, well, I can obviously read it to you, but they're normally quite complex even though they're quite small. So we've got the half sine wave value here. That is, that could be either 100 or 83. It's set automatically when it reads the sine wave and stuff. I'll go over that code soon. I don't know if I put that in this one actually. But either way, it's either 100 or 83 depending on if it's 50 or 60 hertz. So that'd be the half wave divided by that, so therefore you get 1% of the half wave time, because we need to then, because we've obviously got 100 different speeds, so we're taking the half wave, dividing it by 100, we're then timesing that by again 100 speeds minus the fan stall speed. So if I have the fan stall speed set at 20%, that'd be 100 minus 20 would be 80. So 1% of the sine wave, in this case, that's 100 too, just by coincidence, because that's what it is. 50 hertz, half sine wave, 100 half sine waves at 50 hertz, therefore 100. 100 divided by 100 equals 1, obviously. 1 times 100 minus 20, that's for, say, demonstration purposes, would be 80, so that's 1 times 80, so that's now 80. So instead of the half sine wave being 100, we've taken off 20% of the half sine wave. So effectively that's taken off X% from the half sine wave. So that's worked out the minimum timing that the fan could go to, and then we're mapping that minimum timing. So here we're saying, again, we have to invert everything here. It's just the way it works. So this is the current fan speed. So let's say the fan's currently at, for really easy math, 50. 100 minus 50 equals 50. 50 times the minimum timing would equal the fan 1 timing. Even I get confused by how that actually bit works. I literally wrote it a few days ago, but I could just chat on. So let me just think over that again quickly. 100 minus that, fan 1 speed, so that'd be 50. And this is the minimum timing, so in that case, oh, that's the half wave timing. Damn it, I should rename that variable right now to new half wave time. So that would make more sense. So it's basically the fan 1 speed. So let's say that was again 50. 50 times the min half wave time would therefore mean that we're starting from the min time plus whatever the fan 1 speed is. So yep, that's worked out the time that we're going to trim the AC sine wave for. And then exactly the same for fan 2. And then we're going to then we're going to save the min and max fan speed. It's a bit of a long process there because we're effectively saying if the fan speed is greater than 0 and the fan 2 speed is greater than the maximum speed, or the fan 2 speed equals 0. Wait, is that? Yeah, max fan speed 2. I was going to say that'd be a misinterpretation. Effectively, these all start at 0. So if the minimum speed is set to 0 by default, which it is, the minimum value would effectively never be set unless you actually say to it, if the fan 1 speed is, well, you could ignore that bit, I suppose, but let's say if the fan 1 speed is less than the minimum speed, by default that's set to 0. It's never going to be less than 0 because its minimum is 0. So you effectively need to say if the fan 1 speed is greater than 0, because then we don't want to overwrite it if it's 0 anyway. If it's greater than 0 and the fan 1 speed is less than the minimum, well no it's not because it's 0 by default, or the fan 1 speed equals 0, then we can set the fan speed. So basically that overrides it for the first time at 0. So that will set the max and mins there. As I said, this function is placed into the RAM, and this is our task 2 code. This is the code that I've been on about that has to run redonkulously fast. We're using the best that I could achieve for the most lowest level pin writing high and low, effectively digital write high and low. Now it turns out that ESP is a piece of crap, for nicer words, when it comes to minimum timing for setting pins high and low. It really is. Compared to a nano actually poops all over it. I had an interrupter originally calling this part of the code, just that part, but the interrupter took so long to respond. I say so long, we're literally talking microseconds here. The interrupter took about 30 microseconds to respond, and that's just unacceptable. On the nano, I could get it to loop within 4 to 8 microseconds the entire loop, and I could get it to do the interrupt on top, and it would be the highest 12 microseconds. And then this is doing it all at 34 microseconds. Note in mind that this ESP32 is running at 100 and sorry, 240 megahertz, and the Arduino Nano is running at 16, and yet the Nano just is so much better at writing pins high and low. I don't know why, but it just is. I suppose it has less background tasks going on and whatever else. Anywho, I've now took out the interrupter and just placed this in one constant while loop, which therefore is looping as fast as possible, and I'm checking if the pin is high in the most lowest level form possible for an ESP32. You could go one lower. I couldn't find the GPIO library, but I suppose if I included the header file of the GPIO library and looked at the verbose output, I'd be able to see where it is. So I probably could go one level lower to set the pins. Nonetheless, we're saying is the pin high? So effectively, is it started to rise? And can we read the zero cross? Because we don't need to keep reading it, we need to read it once on each zero cross event. If the fan timing isn't zero, so effectively if the fan isn't 100% fan speed, let's turn off the AC. That's effectively saying digital write GPIO pin low. Then we're going to get the current time in micros and add on our fan 1 timing, which I've discussed all this in the previous video, but I'll just go over it quickly. So we've got the time that we want to turn the AC back on, and we're saying we want to finish the cutoff. Exactly the same for fan 2, and here we're locking this bit out until the next event. By that I'm saying when the pin's going high, this is then locked out, and then it's set to false when the pin's gone low. Therefore we're reading each zero cross. If the finish is finished for fan 1 cutoff, well yeah, that's true. It may not be though, obviously, because this is constant looping. But if that's true, because of this, it's set here, and the current micros is greater than our fan 1 timing, then turn the AC back on. Basically, digital write GPIO pin high. Finish fan cutoff equals false, because those micros will constantly be higher than that until it's set again. So we're locking it out. Same for fan 2. And just for my debugging, I was printing out the loop time. I could see that I actually deleted the loop time when I replaced this function up here last night. Oh well, I know how quickly it loops. That's all the code. Now I have to get my mobile out and actually show you this all working. Some people have asked if they can just run this as a standalone piece of code. By that I mean no display, no buttons, just set the variables in the main page and then just let it run. The answer is of course, but if you're going to do that, I'd say I strongly recommend, I insist that you comment out the menu, because then you'll just be constantly getting SBO timeouts, which I believe is set to 1 second. Comment out the screensaver and comment out the buttons, and that's it. Then you could have it standalone and literally just set the values here and just let it run on its own. Otherwise, for those that want to be using a display, I am using a very cheap display here. You can literally get this for £4 to £6. So it's not a money breaker like my other projects. But yeah, so we're using a nice cheap display here. So I will now get my phone out and show you it all working. Alright, so this was the ESP32 project that I was just talking about. It's on a really nice small breadboard. You can get a scale there, that's the ESP32. This is quite a unique breadboard layout, but if you really wanted to go all out, you could start, which I am doing. You could put it on a Vero board, and I'm actually going to not buy one of these. I'm just going to go down to RS Components and get some of the cheap components. I probably could make 10 of those, the price that it cost to buy the 2 that I require for this project. By that I mean that most of the parts come in bags of 10, the resistors, the triacs, the octo couplers. So yeah, I'm gonna put one on there. Basically the display will go there. You got your buttons, ESP32, your output for your DHT, so it can go on a lead. Like I said, both fan controllers will go on the left. And that's about it. You might be wondering what that is. That's a PAM 8430. Oh, I'm getting as close probably. Basically that just controls the volume. You do not need that. You can just have a passive buzzer. Again, I use this to make games, so it's in a different configuration. You could have just one speaker, or you could just have a buzzer. Got a DHT32 there. Got our ST7735 there, with my funny little screensaver. As impressive as that is, it's literally the simplest code in the world. Custom 5-button little Vero board. Costs literally like £1 to make that. Yeah, and that's it. So I think I've got the volume turned off. Just put it back there. I've got a fan running down there. It looks like it's not turning, but that's just the diffuser bit at the front. It is spinning, I'm sure you can hear it. So let's go into the home page. Turn the volume up a bit more. So as I said, home page has a slider. Got our air temperature, maximum user set points and sensor reading. I haven't spent diddly squat time on this graphics display. I literally, sorry, not this, I have on this GUI. I literally ripped the whole GUI in a night. But I'm not saying it's a boasting point, I'm saying that in the fact that it's not perfect. I'm quite fussy with my graphical interfaces. But yep, got our stuff down there. As I said, it's on the home page, it's left and right to that. Up and down is purely for going through pages. So press down, just a nice simple menu. Really easy to code. Just showing all the values. That's what you have. So go into the temperature page. Air temperature minimum target. Set it to whatever you want. Could hear the fan speeding up then. Yes. Obviously must be just around that. Got our max temperature target obviously. And then return to the menu. Humidity, same kind of stuff. Min max, return to menu. Fan 1, minimum speed. Now you're probably wondering why is that not going any higher. It's because the minimum speed cannot be greater than the maximum speed. Therefore, there you see. The fan's actually going to probably start speeding up. Just for giggles, let's turn that down now, and we'll actually turn the fan on a fixed speed so we can play with that, and you can hear it ramp up. Fan 2, exactly the same kind of stuff. History, as I said, record our maximum mins. Can't adjust them, as I said. You can only go up, down. This is what I mean by it's not finished. Those probably could be centered a bit better. Need to go down a little bit, don't they? Probably about 6 pixels. So what I didn't explain it. We've got temperature, humidity, fan 2. Turn to menu. Got a settings page. Oh, I don't like that. It needs to be better. Now it should be said I made all these fonts myself, every single one. So don't knock them. Disable. Well, that's that. Temperature and Fahrenheit. Enabled or disabled. Yeah. Speaker. Off. Leave it on for now. Display timeout. Turn it off if you want to, or increment it as you please. Note in my little attention to detail there. Minutes or minute. Fan 1 fixed speed. We're going to turn that on. Damn it, it's right to turn it. Enable. We haven't got a fan 2 plugged in, so let's leave it like that. Temperature control. Enabled. Humidity control. Enabled. Fan 1 stall speed. I explained this earlier on. I was just playing the values. I could probably turn that down to about 26% for my 150mm fan, but that's good enough. Just set that to whatever. Fan 1 enabled. Yep, you can turn it off if you want, so that just basically means no output will be put on for fan 1 or fan 2, respectively. Return to menu. That's it, so nice and simple there. We set fan 1 to a stall speed, so let's a fan one's in a fixed speed, so we expect to see the speeds are the same, therefore incrementing one increments the other. So fan one's going at 30%. I don't know whether to put the phone down there and you hear it ramp up, or leave the phone up here. Either's good. You can't really hear the noise difference from about 80 to 100, it just starts to howl. But yeah, and then slow it down. It is still spinning. And there's just a demonstration to show that it's blowing stuff away. It is still going at like super slow RPM. So yeah, that is. Obviously, you could go right down to 1 because I've mapped it effectively, so that this 1% is effectively 30%. Ramp it back up. And I suppose that's it. That is how to make a AC fan speed controller for your temperature and humidity with an ESP32 and the Arduino IDE. Thanks for watching.